Yeah, okay. I believe we're streaming live. Let's have a look. We shall have a look. Yeah, live. Let's have a look. Right, we've got a bit of a sound going on there. Bit of an earthing fault for some reason. Yeah, let's get rid of that noise. 1, 2, hello. Right, we've got a bit of a sound going on there. Right, let's try and get rid of that buzzing sound. Yeah, let's get rid of that noise. Yeah, I've got an earthing fault there. Let's try and get rid of that buzzing sound. Let's get rid of that noise. Yeah, I've got an earthing fault there. Right, I'm just listening to myself, alright. Yeah, I moved my microphone and for some reason it's it's picking up main sum. Right, so how can we get rid of that main sum? Right, so how can we get rid of that main sum? Right, okay. Let's try that. Still there, is it? Let's try that. Still there, is it? Yeah, see the bit there. Right, so today we've got a... I may just mute that. Yeah, so today we got a Novoferm 3-phase industrial door controller. Not sure whether it blew this up or whether it was blown up, but we've got no voltage to the microcontroller. We've got 24 volts. We've got 24 volts go into the board, and we need 12 volts to feed the safety edge system, and also off that 12 volt I'm pretty sure it gets turned into 5 volts for use on the microcontroller or all the logic circuit. And we've got 24 volts responding on the inputs, 'cause that's just LED control of an input. It doesn't, there's no logic to tell it to switch on, it just switches on. Right, I've just got to wet the sponges are dry. It's the trouble with these sponges, they go dry. You have to keep wetting them. On the soldering iron. That's okay. Right, so what we got here is I've had a quick look around with a meter this morning, and I seem to trace the problem, not sure if it's a problem yet, to a, looks like just a diode, probably a protection diode I would have thought, and it looks like that's going to ground, going to earth, and it's a bit of a bugger panel to test, because you've got to keep flipping it over back and forth to get at the wires. They don't make these things. I'm just going to have a sip of tea. They don't make these things easy to work on, but they don't want you to work on them. Basically, they want you to just buy a new one. You know what I mean? Right. Okay. So let's get the microscope onto the one in question. What I think the problem might be. Hold on a second. Let's just get this into a position where I can set this light, set this up. Alright. bit awkward. Could do one of those expensive microscopes that you can pull over. Right, let's just swap over to the other camera a minute, hang on. Right, let's try and focus it in. Right, here we go. Yeah, that's facing the wrong way. I need to rotate this because otherwise I'll be working. Looking at something, and my eye to hand coordination will be going the opposite way. Right, that's not really good focus, is it? That's better. Right, see that little bridge rectifier there? Let's try and point to it. Let's get a meter on it. Let's put a meter in the view. Hang on. Right, I've got a meter just on bell, and this bridge rectifier, I'm sure it's done its job and protected the circuit. And you can see I've got 0 ohms going that way. Swap the probes around, and 0 that way, so that's a dead short. And the one this side of it here, that is ground, because we've got a device over there. Let me just I wonder if I can zoom out a bit further. Let's get up a bit more and see a little bit more of the circuit. Hold on. Yeah, that'll do. Let's focus that in. Right. So that device there is a 7805, some kind of 7805 voltage regulator. I haven't found the 12 volt yet for some reason. Why haven't we found the 12 volt? Let's just make sure that is a 7805. I'm pretty sure I worked it out to be a 7805. I'm just going to go handheld a minute. Let's have a look. Right, so it's an L7805 CV. So that's what provides the circuit, all the logic, all the ICs and stuff, all that stuff there. That PIC microchip, the PIC is a 16C73B. I've had a look at that on a diagram to find out where the power supply. That's how I worked out there was no supply going to it. So we've got another device here. I'm not sure what this one is. Let's have a bit of light on it. Hang on a minute. Sorry about the handheld movement. It's not easy to see that one. Not easy to get the light on that to have a look at what that is. Oh, here we go. What is it? It's a bastard. I don't know what that is. Could be a FET or something. I don't know. Anyway, right. So the thing question. Let's get back to. Let's get back to an overview of that. Focus in. Sorry about that. I'm gonna have to get a better one of those ones that's always in focus. Well, so basically what we've got going on here is the heat sink there and the tab on this 7805. I know from experience that tab is ground and the middle pin's ground, and the left hand pin is the input, middle pin's ground, and the right hand pin is the output. So at the minute there's no voltage on the input. I've got nothing wired up at the minute, but I've done a test while it's still, it, wired up. So there's no 12 volt coming in. So I'm and I've worked out that there's a bridge rectifier a bit further up there. Let me just I can't show you that, but it's a bridge rectifier, and it comes down, the wire comes down from it, from the plus pin down to this here. And if I see what I'm getting in at the minute, I reckon if I do the input as well, am I getting dead short on the input? No. See, I'm getting both sides of that device, I'm getting a short. So I think that is short circuit. That can you see that? Yeah, that device there. We can have a zoom in on it and see what it is if you like. Let's go down and have a look at it. Get the part number up and have a look. Just drop it down a bit further. I've got to sort this focusing bits and this out, haven't I? Alright, can't really see that still, so let's get a bit closer. Let's get right close. Let's get the part number up. Let's alter the hard to see that one. CM2214, whatever that is. Don't know. Let's try it. Let's see what comes up on the old Google. Right, so we got CM2214. What is that? Nothing. It's an aeroplane flight. It's a bridge director. It's a diode. Some kind of diode. Yeah. Fabricated Scotty diode. There we go. So it's basically I'd use one of those across a supply just to short it out. For reverse polarity and whatever. Yeah. But I think that's gone anyway. So let's get that off the board and get in shorter time. I've got to go to work. Right. Yeah, let's get that off the board. Okay, I'm going to back this off. Back this off, we'll switch to the other one. Hang on. Alright, let's back this off. Get that out of the way. Okay. So we're gonna put the soldering iron on and get that off. And I could use the hot air gun. I think I'll just put the soldering iron on. Let's let that warm up a second. So that's a protection diode. So in theory, you should be able to take that out. Just take it out altogether, and it'll still function. It's definitely shorted across the ground. Well, I say that, but we won't know for sure till we take it out. It could be another device that's shorted to ground, but at the minute that's the only one I can find. There's definitely got a short on it, so let's take that out. Get some tweezers ready. I wonder if I should use the hot air. No, we'll destroy the capacitor next to it, and this plastic fuse holder will destroy that as well. So we'll have to do this the old-fashioned way. Right, we're up to temperature. Okay. Let's how am I going to do this actually? I can do with the two irons. Have to, let's get a bit of solder on it. Oops. Let's just try to see if it is awkward. Let's turn it around a bit. And I'll make it easy. Should just warm it up with an iron really, but shit, how do I do that? You've got a bit of bloody solder on the side there. That's gone. Right, so we can Kapton tape it. Yeah, let's do. Tell you what, we'll try a different method. We'll put the hot air gun on. Bit of Kapton tape around the stuff. Bit of Kapton tape just to protect the plastics around it. I need to get both sides warm at the same time. If it was a capacitor or with something with a flying lead, you could lift one lead, then move it, and lift the other. With these things, they're just flat on the board. Now you could just rip it out if you wanted. You could literally just rip it out. Where's my knife? Yeah, you could just rip it out and then. Right, so I'll cover the. You can hardly see this stuff. Yeah, cover the capacitor. Let's cover the fuse holder. Cover the fuse holder, and the resistor will be able to take a bit of heat. There's no other surface mount stuff there at the minute, so okay. Let's give it a bit of protection. Right, out with the hot air gun. Let's get it up to temperature. Yeah, that's okay. Right, pliers. So you need plenty of space. If this is short circuit when I take it out, stands a good chance this is the problem, which means it's done its job admirably. Excuse me. Yeah, I probably blew this up actually. Right, we're off. Okay. Let's put the hot air gun out of the way. Make sure I don't set fire to the wall. It's quite close to the wall. I need a piece of steel up against the wall. Right, let's do the little test. I'm just going to measure this while it's out. Let's hope this is a short. If it's not, it'll be something else short. Right, we've got a short that way. Turn it round. Yeah, we've got a short both ways on that. Okay. So, let's have another check now. I'll leave the Kapton tape there for a minute. Let's just turn that off. Turn the iron off a minute. Right, let's do another test. Let's do a test of the pad there. There's no longer a short now. Yeah, there's no longer a short to ground. Oh, there is there. That's right. The one side's ground and the other side should be the input, or is it the output? So this heat sink is actually plus. That's weird. Let's just make sure. Let's find nice ground. Where's the ground? That's a weird one. It's a strange one. So let's say that is thought that would be plus, minus. It's just finding the right minus. Anyway, we can power it up and let's see if we got any. Let's see if we've got any 5 volts on the logic. Without that, I'll just check, make sure I haven't left any solder on the board. Where's my magnifying glass? Just make sure there's no solder flipped anywhere, shorting out. No. Okay, so we need a power supply to it now. We've got a little connector block here. Old Maplin Electronics, snap on, quick connect, there it is, quick test. So we need a little bit of cable now to join. Hope this microfiber cloth's not conductive. I better put it on some plastic. Let's put on some plastic. What plastic we got? We got some mats somewhere. Cutting mats. I saw them the other day. What did I do with them? Cutting mats. Right, there we go. Cutting mat. Sorry, I'm still in my dressing gown. Dear me. Should really get some clothes on before I do this, don't mind. Right, so I've got a cutting mat. Let's turn it over. A bit of paint on it. Oh well. Right, let's put that there. So that's isolated on a cutting mat now, so I can wire it up. And I need some wire now, so I need to steal some wire from something. Right, let's find a bit of wire. Dodgy lead or something. Plenty of wire. Normally, not here though. What have I got? Wires. Never got a bit of wire when you need it. Bit of wire, please. What we got here? Probe leads. No, I don't use that. Wires coming out the edge, remember? Where are you? There's all too many wires, remember? Not today. Put them all away. Just the job I got here. I got, let me just tie myself back up. Oh dear. Anyway, right, here we go. I got one of these, I'll say foreign, let's say EU or German adapter. Right, so I'll cut this up. Let's just cut that up. Where's my cutters gone? There they are. Going crazy. I'm going to repurpose this lead. It's got an earth as well. Fair play. Right, we don't need the end of it, so let's cut that off as well. Stanley knife. Now we'd have put nothing. So I still haven't got round to doing any Amiga stuff. But I've got lots going on, so we'll get there one day. Hopefully I can get this wired up and not get electrocuted in the process. should have 3 phases, but we're not powering the door, so it shouldn't make any difference. I'm just stripping a cable back. Not prepared at all, no preparedness, sorry about that. Anyway. Right. Let's get this stripped back. Might as well stick the earth in as well, I suppose, even though it probably doesn't go far. So hopefully the 5-volt logic will light back up again, and the 12 volts in the process. And if it does, hunky dory. Still doesn't mean it's gonna. Hopefully that bridge, that Scotty diode that's put across the supply, did its job. Hopefully that did its job, and we need that in a minute. Yeah. Right. Let's. It looks like the live comes in on this one here, L2. So I'll try L2. You can't even see that, can you? Hang on then. Let's move it over. Yeah, always wire the end that feeds the thing, that wires into the board first, and wire your supply. Let me get rid of that microscope. You can't see. Microscope, where are you? There it is. Right, there you go. Okay. Right, yes, I'm just wiring in the. Well, let's put the neutral in as well. Might need the neutral. Hopefully, this will work neutral. Otherwise, if it doesn't work from neutral, we need 3 phases. They'll basically add it, phase earth. Okay. Let's just do a bit of a basic check. Quick basic check here. Let's move up a bit. That's it. Right. Just want to make sure that that earth is the actual earth. It's earth around here. Yeah. Yeah, that is the earth. Yeah. Let's just make sure. Yes, that's the phase we want. Neutral. Don't know where that goes off to. Anyway. Oh yeah. So hopefully that's enough to get this thing running. Right, so what we'll do now, put the other end in the Maplin quick test. Well, I don't know if it is a Maplin one, they sell it, so there's probably somebody else. I don't think they would have commissioned it. They may well have done, but I doubt it. Somebody probably just came along and decided to say, do you want to buy some of these? Right, so we've got our lights on here, put the earth in. Neutral next, and it's 13 amp fuse in this, so it's not going to blow up anyway. It didn't blow up while we had it in circuit last time, so put that somewhere where I can undo it quickly. Okay, so we're still on the board, isolated. Here we go then, ready for a bang. Let's go, ready, here we go, ready. Okay, nothing seems to be happening. We've got no stop circuits in, but we can do a few basic checks on voltage. Let's do the voltage check. We're on volts now. Let's see if we've got 12 at 24 volts. 1.8 volts DC. Oh, hang on. What have we got? Right, I think we're going to have to connect the stop circuit up here, the interlock, the emergency stop, there. Okay, let's just temporarily undo that a minute, and we need a bit of cable again. Never got cable when you need it, interlock, safety. I need a bit of cable. Have I got any around? No. I ended up cutting all that, didn't I? Didn't leave myself a bit to join up stuff. I'm gonna have to get some little reels of cable. What we got there? I don't know. Hold on a second. Oh, here's a bit. There's a few bits. Right, let's get these bits. There you go, I'm gonna rob something. Yeah, the power drops out on this when so how many stops I got? One there. Triple button stop and 24 volts. So that's gotta be. Yeah, I better make another wire. Two wires I need probably. Yeah, it takes time, doesn't this? Anyway, how long we've been going for? Does it even tell you? I can't even see that. Oh, hang on. 30 minutes live. Yeah. Right, let's click the stop circuit up, make sure he powers off. Yeah, it is. Where's the stop gone? There it is. Emergency stop. Get the emergency stop wired up. Okay. There's another version of this that's got the rest of this bit here populated, but that's to drive inverter. That's if you've got a 3-phase inverter on it. Basically the motor windings go to the inverter, and then you wire your motor to your inverter, and then you connect all your logic up to your inverter. It does all reversing and everything off your inverter. Right, so we've got a stop circuit there. We want another one on the buttons here. We've got no limits. That's going to be another problem. Yes, that'll be another problem. So we might need limits on this. We definitely will. Gonna need more wire, I think. Anyway, let's do it bit by bit. We don't need the up and down. We just need the button stop. Yeah, it's a bit time consuming anyway. What time we got? 20 past 7. Oh dear. Always running out of time. Right, need a bit more wire. Let's rob something else. Right. Yeah, it'd be nice to get this working. Look, because I don't like blowing stuff up, and if I blow it up, then I want to get it working. It won't close because there's no safety photocell connected. Right, so up and down limit and safe. All that's got to be working for it to operate. But not to power up. Yeah. I don't know. Let's make maybe I could do with more wires. Need to get 3 wires into the one. Yeah, what I was trying to do, I had a new motor rewound, and then the what I thought was the old thermal breaker in the motor. 2 wires were cut the same size. Made me think that so it made me so up limit. So we'll say it's down. No, we'll say it's up. We'll make the up, and then at least we could take it up if we make the up. Needs another one, really. One more wire. Let's get one more wire, and then we can operate. One more wire. Yeah, they'd cut these 2 wires the same, and when I tested them after we'd blown it up, or well, it blew a fuse actually. It blew that fuse. So, and I suspect it blew that fuse because it took that out. Right, so we can do. I'll have to power this off every time we want to do a stop or a close, I think. Yeah, it's a fiddly job trying to, unless you're repairing panels all the while, it's you won't be set up for doing tests, so it's a case of having to get these wires and stuff. If you're doing a load of panels in one go, or regular, you'll have all these links ready to go. Right, so these are all normally closed inputs for the safety, open limit and close limit. So you've got to wire them out. Stop circuits normally closed, so there'll be one more, the photocell. So your photocell input and 24 volt, that's got to be wired. Another bit of wire. There's a bit of wire. So I couldn't work on my project this morning because I'm having to sort this out. Hopefully it'll be okay and it'll go back in today. Keep the customer happy. Right, so 24 volt there. This is the where the photocell would wire into this bit. Go from 24 volt to input. There. So hopefully the only thing else that could stop it is this Faber. This is the safety edge input. Your brown, green and white input off your optical safety edge. I can override that on the dip switch up here if I put both these switches up. It's in service mode now. So, right, let's give it another go. Let's just give it a check over. Nothing else that needs to be wired. Interlocks are in, yeah. Nothing else, so let's give it a go. Ready? Here we go. Alright, still got nothing. Why is that? Let's do some measurements. Make sure we got some power going in. So we got our 230 volts going in, yeah. And let's see if we got any 24 volts. Yeah, oh, we got 29 volts now, so we're satisfied criteria wise. Now we've still got no lights on. We've got lights. You can't see them lights. We've got some lights across there, but none up here. What is that? Let's just test for 5 volts. And so let's find a ground reference point. So there's our overall ground there. And that's there, yeah. Okay, go down in there. What we got? 0.7 of a volt. See if we got any input coming in. I want to keep my hand still. 1.2 volts. See, there's not enough volts going in there. Let's just measure this. Oh, I took this off. 1 volt. That's ground. Not enough voltage. You ask yourself why that is. I was hoping that would come up in voltage. Yeah. May have taken that out. That's a bugger, isn't it? Unless that's not the same ground. Maybe they've isolated the grounds. Let's try a different ground. Let's try against. Well, I would expect to see some lights on over here. LEDs. So let's do that. That's the output. Yeah, it's just the same output there going on. Yeah, not enough voltage going in. 1 volt. So could try the bridge rectifier. Let's get a negative. So we've got a negative there, and then we've got the voltage coming down here, 1.9 volts. 21 volts there, 18 volts there. You got a that's not really a good place to put the probe, on top of the capacitor steel. Tell you what, let's put it into the negative. Yeah, let's screw it into the negative. We've got negative 24 volts. Looks like that's common throughout, so let's put it into there. Okay. Right, what we got here? This 1.2 volts DC. That's just, is it DC? Yeah. Let's have a look up here. 1.7 volts. So we haven't restored our 5 volts yet. Could this be short, taking it to ground maybe? Shorting out the input. 1.4 volts coming in, 0.7 volts coming out, so that looks about right. Let's just check the fuse. 28 volts. No, that's good because it's coming out of here. Yeah. Right, so what else can we do? We've got no 5 volts on, we've got no 12 volts on either. The brown is the 12 volts. Got nothing coming out of there. So the white on these optics is the minus and the green is the signal. So that's connected to ground, and the brown comes through here. And I just haven't got enough voltage, we're being dragged down somewhere. So we're not getting our output. The next thing we can check is to see if we're getting AC coming out of the transformer. Gonna have to flip this over for a minute. Right, I'm going to take the power supply apart. I've lost something or other there, I don't know what that is. Anyway, right, let's turn this over. Not for the weary or the faint-hearted, never do it while it's plugged in. All this is live, normally. Right. Okay.